I discussed about speed and velocity in the previous video, but I'm going to be talking about acceleration. So acceleration acceleration occurs when the velocity of a body or an object is changing, and it can also be said to be the rate of change of velocity with time. You can see that the key word in acceleration is change, because the first definition of acceleration, velocity is changing. Also, this one is also changing. So that's the key word, and we can note that change. And change means, or change will occur when there's either a decrease or increase in something. It can be anything: money, clothes, age, anything. And let's take for instance, we have an axis. This is in meter per seconds, and we have here to be the starting point: 0, 1, 2, 3, 4, 5, 6, and goes on like that. This is like only having the positive axis. And we have someone standing at this point, at the starting point right here. So, and the person now gets himself to this point, and if you look at the axis, well, that means there's a change in the velocity. I'm having this unit here, or can use it to represent speed. So now if we want to try and say the change in the person's velocity or speed, this will be 4 minus 0, because this is the initial point and this is the final point. And this will be, let me write it, initial point, and we have the final point, and this will be 4 minus 0, and that will be 4 meters per second. Also, if we have someone moving at this point, let's imagine the person started from this point here and got to this final point here. And this would, the change in this person's velocity, because this is a velocity axis, would be, this will be the initial point, then we have the final point. So the change in this person's velocity would be 6, take away 2, and we have also 4 meters per second. So that's the crucial thing about acceleration. There must be a change in the velocity. So doing this on a newer page, let's take for instance, we have a ball on a smooth inclined plane being held at the top. So we have our inclined plane, something like this. So we have a ball at the top here. So this is the ball being held at the top here, and when left by itself, it begins to roll downward. We see that the ball begins to move downward, and there is a change in the velocity as it moves downward. It moves faster till the ball hits the bottom of the plane, and we find out that while the ball is in motion, the ball hits the velocity increases till it gets to the bottom of the plane, and the ball is said to be accelerating because there's a change in the velocity. Or if a car starts from rest and moving due south, we have a car moving towards the south direction, and we started to move towards this direction, the south direction, and has a velocity of 2 meters per second after 1 second. Its velocity has increased by 2 meters in 1 second, and it is also having a velocity of 2 meters per second due south, or 2 meters per second squared. So we can therefore say that the acceleration of this car is 2 meters per second per 1 second, or after 1 second, and that's also the same thing as having 2 meters per second squared, because when we have 2 meters per second divided by per means divide by another second, sorry, divided by another seconds. So if you change this division to multiplication, this will be 2ms times 1 over s. So we're going to have 2 meters over second squared, and we want to write this in this form, so that's 2 meters per second squared. So we can now have our formula for acceleration to be acceleration is equals to velocity change all over time taken to make the change. So acceleration can be said to occur when an object increases its velocity. So there must always be an increase in the velocity. Like this ball that was rolling down this inclined plane and got to the bottom here. So that means there's always meant to be an increase. So when we have an increase in the velocity, we have acceleration. So now what will now be coming to your mind is that when we now have a decrease in the velocity, what should we have? Then we have a newer term, which is negative acceleration or deceleration. Increase in the velocity, we have acceleration, and decrease in the velocity, we have deceleration or negative acceleration. Because if you remember, when I was explaining change, we could have change to be decreasing or increasing. So that's why it is in two ways. And we can take an example also on acceleration. Suppose a car starting from rest accelerate to a velocity of 20 meters per second in 5 seconds. Determine the acceleration. Here now we have at rest. So the initial point, the initial velocity would be 0 because it is not moving. So that's why it is from rest. And we have the final velocity to be 20 meters per second. And we have the time taken to make that change in the velocity to be 5 seconds. And from our formula, acceleration is equals to velocity change all over time taken. And if you remember, when we wanted to get for velocity change, we subtract our initial from the final, and velocity change will be 20 minus 0, and we have meters per second, and we have time taken to be 5 seconds, and we have this to be 20 meter per second all over 5 seconds, and this will be 4 meters per second squared.